All right, this is section 1.6, and today we're going to be talking about inverses. So in mathematics, most of our, I should say all of our operations have an undoer, or they have an inverse. So inverses, the easiest way I have found to describe them to kids is they're operations or functions that undo each other. And you already know plenty of inverses. Addition's inverse is subtraction. Multiplication's inverse is division. There are lots of these instances in math, and you have seen plenty. So one we're going to do, we're going to graph the function y equals x cubed and its inverse on the same set of axes. So what's the inverse of a cubed? Like what would undo a cubed? A cubed root. So think about if what would undo a squared, square root, a cube root, a fourth power, a fourth root, and then an x cubed. I'll grab my calculator. Show you how to graph it on there. So oh, look at that, I was doing it already. Here's my x cubed function. I'm going to hit zoom 6. And that is what it looks like. Kind of that basic, like snake looking function that you've graphed before. Goes through 1, 1, and then -1, -1, and then 0. And it kind of just makes this snakish, kind of weaves its way through that 0, 0. A cubed root function, just have to turn this one back on. So now we're going to graph just the cubed root function. I'm going to hit zoom 6 again. And it just goes the other direction. So it's almost like its exact flip. Still going through 0, 0, 1, 1, and -1, 1, but the function now looks like this. And that is the inverse. So if we were to look at the XY charts, we'll do y equals x cubed first. That's the easier one to do. So if I pick 0 and 1 and -1, what's not exciting about that is we're going to get the same values for the function and for its inverse. So I'm going to pick one more number. I'm going to do 2, which you can't quite see on the graph. But if I put a 2 in here and cube it, I'm going to get 8. And if I put a -2 in and cube it, I would get -8. And this is the kind of plugging in we're doing. So if I do -2, it's not in parentheses, it's just -2 cubed. If I were to flip-flop it and do the XY chart for a cubed root, now there are a lot of things we can cube root, but they end up being decimals. So I'm going to pick ones that I know cube root nicely. So the cube root of 0 is 0. That one we already talked about. We knew they were going to be the same. The cubed root of 1 is 1, and the cubed root of -1 is -1. Then I'm going to go out to this 2, 8 area, which worked out so nice for my x cubed function, and see what it does as a cubed root function. So I can't really go out to 2. That looks like it's going to be a decimal. What's interesting actually is if you go out to 8 instead, the cubed root of 8 is 2, and the cubed root of -8 is -2. So when you look at inverses, their x and y charts, xy chart flips. All the x's become the y's, and all the y's become the x's. So if you ever need to graph a cubed root function or a fourth root function by hand, you can actually do the xy chart for it, flip the xy chart, and then you've got all the data you need to graph. So some y equal x cubes, some cube functions do not have an inverse. What would they look like? They look something like this, where they don't exactly match up. Like this guy had matching points, the 1, 1, it was symmetric, everything was looking good. This one not so much. We don't go through 0, 0. I have a low point here at +1, like almost 2, but if I go to -1, I'm not seeing that same oppositeness. So this one actually does not have an inverse. There's not an opposite to that. So how are we going to know when we look at functions whether or not they have inverses? Well, you've actually learned about the vertical line test. That tests if something is a function. The horizontal line test tells you if something has an inverse. So not all functions have inverses. I just pointed one out to you. For a function to have an inverse, it must be 1-to-1. So that means for every x value, we get one y value. You can't have any repeats. So something that you've graphed a lot, that we're going to graph in a minute, parabolas, I'm going to show you how those, even though they're super familiar to you, do not have an inverse. So the vertical line test tells us if it is a function. The horizontal line test tells us if it has an inverse, which is the same as saying if it is one-to-one. They are synonymous. Being an inverse and being one-to-one are the same. So let's graph that parabola. That's a function you have seen a lot over the years. So 0, 0, 1, 1 has its mirror image, and then 2, 4 in its mirror image, and it looks like that. So vertical line test would tell us this is a function. Yep, totally passes. Function, check. Does it have an inverse? As soon as I draw a horizontal line, I hit it twice. That means it is not one-to-one. There are two values here that go to one y value, so there's two x's that go to one y value, so that is not one-to-one. And when I drew that horizontal line, I hit the function more than one time, so that means it does not have an inverse. Although there is a way for us to undo a squared, that is just a square root. We know how to do that. The problem is the negative values. So when it says find the inverse and graph it, we kind of can, fx, we know that this, that the inverse of a square root is the inverse of a squared is a square root. I said it backwards. The problem is that will only give us the positive values. It will only give us these ones. So we would need to have the plus and minus version in order to be able to graph the inverse. But this isn't a function. So if I draw my vertical line test, fails VLT, not a function. So even though we could do the math to find the inverse of this, it doesn't actually mean that the inverse exists. I mean, I know that I graphed it visually, but the inverse is not a function. So that means this function doesn't have an inverse. It has something we can graph, it has an equation we can figure out, but it's not technically an inverse because it's not even a function. Oh shoot, mine don't have graphs. Hopefully yours do. So the first one is, does this have an inverse? And it looks like this. So first off, is it a function? Yep, passes function test. Does it have an inverse? If I draw a horizontal line, I hit it twice every time, so that is a no. So no inverse, excuse me, it fails the HLT. The other one you have looks something like this. We kind of did that graph already. So does it pass vertical line test? Yes, it is a function. Does it pass horizontal line test? Yep, everywhere I draw a horizontal line, I only hit the function once. So this has a function, I'm sorry, this has an inverse. It passed HLT. What if I don't have a graph and I have an actual equation? How will we find the inverse? So the first step to finding an inverse is to replace that f of x with a y. And then we're literally going to switch the x and y. Kind of like how our xy charts on the inverses are the flip of the regular xy chart. We're going to flip where our x's and y's are. Literally change their places. And now we're just going to solve for y. So in order to undo a cubed root, I would cube both sides. So I have x cubed, and then the cubed root and the cubed will go away, so I have y minus 5. And then I will add 5 to the other side, so I have x cubed plus 5. And when we annotate that this is now an inverse, we put a little -1 there, and that is your inverse. So even if you don't have a picture, we could still find it algebraically. Let's try that a couple more times, finding the inverse of each of these. I'm going to put my y there. I'm going to flip-flop them. And now I have a variable in the denominator, which is a little wacky. So I'm going to multiply by that whole denominator to raise it up. And they'll cancel. Remember, you're solving for y, so I'm just going to divide by x. And that's okay having that down there. Since we're solving for y, y is the one we want to get up out of the bottom of a fraction and have it kind of sitting on that main level. And then we'll add 2 to both sides. There's my inverse. So some kids think they can look at this and go, well, if I have a 5 on top, I must be dividing by 5. Didn't turn out that way. Or if my x is on the bottom, my x is going to have to be on the top. Didn't turn out that way. I did have a -2 that turned into a +2, but up here it was beneath the fraction. Here it's not. So please don't get caught looking at this and thinking you can just opposite everything and that it'll come out to be the inverse. You have to really go through the algebra to get there. So next one's going to be y, and then cubed root of. We'll switch the x and y. And now to get rid of a cubed root, we're going to cube both sides. If this 2 in the bottom, so in order to solve for y, we're going to multiply by 2. And then just to slide that 1 over. Don't forget the -1 on your y so that everybody knows that this is now the inverse that you found. Last one looks a lot like the first one, so y equals 5 minus 3x. Switch the x and the y. Multiply by 2. And then remember you're solving for y, so I'm going to move the 5. And then all I have to do is divide by -3. Alright, so we've talked about how to find an inverse both visually using the HLT and algebraically. So switch your x and y and then solve for y.